Research reasoning refers to the process of drawing conclusions based on evidence and logic during the research process. It encompasses the methods and approaches used to analyze, interpret, and infer findings. Here's an in-depth exploration of research reasoning. 1. Types of research reasoning. A. Deductive reasoning. Definition: moves from general principles to specific conclusions. Process: starts with a theory or hypothesis, examines specific cases to test the hypothesis, derives a conclusion that must logically follow from the premises. Example: if all humans are mortal, general principle, and Socrates is human, then Socrates is mortal, specific conclusion. Strengths: provides logically certain conclusions if premises are true. Applications: common in experimental and quantitative research. Sure B. Inductive reasoning. Definition: moves from specific observations to general conclusions. Process: observes patterns or regularities, develops broader generalizations or theories. Conclusions are probable rather than definitive. Example: observing that the sun rises in the east every day leads to the generalization that the sun always rises in the east. Strengths: allows for the discovery of new theories and patterns. Applications: common in exploratory and qualitative research. Abductive reasoning. Definition: infers the most likely explanation for an observation. Process: begins with an incomplete set of observations, seeks the simplest and most plausible explanation. Example: observing wet streets and inferring that it likely rained. Strengths: useful in forming hypotheses or initial explanations. Applications: common in diagnostic, investigative, or early research phases. D. Analogical reasoning. Definition: draws comparisons between two similar cases to infer conclusions about one based on the other. Process: identifies similarities between two systems or phenomena, transfers knowledge from one context to another. Example: comparing the immune system to a military defense system to understand its functions. Strengths: facilitates understanding of complex or unfamiliar topics. Applications: used in case studies and interdisciplinary research. 2. Importance of research reasoning. Ensures rigor, promotes logical consistency and validity in research. Facilitates discovery, helps identify patterns, relationships, and explanations. Supports decision-making, provides a structured approach to interpreting findings, enhances credibility, demonstrates the logical basis for conclusions. Characteristics of good research reasoning. 1. Logical consistency. Arguments and conclusions must follow logically from premises. 2. Relevance. Focuses on evidence directly related to the research question. 3. Clarity. Clearly defines concepts, premises, and reasoning processes. 4. Objectivity. Minimizes bias and relies on evidence. 5. Adaptability. Adjusts reasoning based on new evidence or insights. Applications of research reasoning. A. Hypothesis testing. Deductive reasoning is often used to test hypotheses against empirical data. Inductive reasoning may identify patterns that form the basis for new hypotheses. B. Theory building. Inductive reasoning is commonly used to develop new theories from observed data. Abductive reasoning may generate initial theoretical frameworks. C. Data interpretation. All forms of reasoning are used to analyze and interpret qualitative or quantitative data. Analogical reasoning can contextualize findings by drawing parallels to known phenomena. 5. Challenges in research reasoning. 1. Logical fallacies. Errors in reasoning, e.g., hasty generalizations, circular reasoning, can undermine conclusions. 2. Bias. Confirmation bias or researcher bias can distort reasoning processes. 3. Complexity. Handling multiple variables or conflicting data requires careful reasoning. 4. Incomplete evidence. Limited or ambiguous data can complicate abductive or inductive reasoning. 6. Improving research reasoning. 1. Develop critical thinking. Question assumptions and evaluate evidence rigorously. 2. Use structured frameworks. Employ systematic approaches like Toulmin's model of argumentation. 3. Incorporate multiple reasoning types. Combine deductive, inductive, and abductive reasoning for comprehensive analysis. 4. Engage in peer review. Solicit feedback to identify gaps or weaknesses in reasoning. 7. Examples across disciplines. Social sciences. Deductive, testing theories of human behavior. Inductive, observing social trends to develop new sociological theories. B. Natural sciences, deductive, applying laws of physics to specific experiments. Inductive, discovering patterns in ecological data. C. Business and management, abductive, inferring customer behavior based on limited market data. Analogical, using case studies to apply successful strategies across industries. D. Healthcare, deductive, testing drug efficacy in clinical trials. Abductive, diagnosing illnesses based on patient symptoms. 8. Reasoning in mixed methods research. Combines quantitative, deductive, and qualitative inductive approaches. Enhances robustness by validating findings through multiple reasoning paths. 9. Recent trends in research reasoning. AI and machine learning. Use data-driven inductive reasoning for pattern recognition. Interdisciplinary reasoning. Combine reasoning approaches from multiple fields to address complex problems. Dynamic reasoning. Adaptive reasoning models that adjust as new data becomes available. 10. Ethical considerations in research reasoning. Avoid manipulation of evidence to fit preconceived ideas. Clearly communicate limitations and uncertainties in reasoning. Ensure transparency in the reasoning process to allow replication and validation. Research reasoning is the intellectual backbone of the research process. Mastering different reasoning methods enables researchers to draw meaningful, reliable, and valid conclusions, ensuring their work contributes effectively to their field of study.